Deep learning is basically a subfield or a subset of machine learning. It's relatively new, and the inspiration of deep learning comes from the human brain. So basically what we have tried to do with deep learning is model the human brain, the neural network of the human brain in computers and make it work that way. Have you guys heard of the term neural networks? It's a very publicized term. So this is the basic structure of a neural network. Those circles you see, right? They are basically what are called as we call them neurons, named after the neurons in our brain. And how many layers can you see? 3 layers, right? The first layer, there are how many neurons? 2 neurons. The second layer, you have 3 neurons, and the final layer, you have 2 more neurons. So all of them are interconnected. Each layer is connected to the other layer. So basically, in a neural network, like I'm not getting too much into the technical details. You sort of have an architecture like this. You give it an input. It learns how to do the task in the layer, in the hidden layers, and it gives you an output. That layer in the middle, right, is called a hidden layer. So this is a very simple neural network. The neural networks you guys use and all, traditionally, it has about 1 million layers. So between the input and the output, there will be 1 million of those hidden layers. Clear? One of the reasons why machine learning and why deep learning is so successful is because data is everywhere. Everyone is a data point. Everybody has social media, everybody has a smartphone, and you can almost learn anything you want about the person. So the data is available, and all types of data is available, and we have the methods to capture and store this data also very efficiently. You guys have heard about cloud and all that, right? So, big data. So we live in a world where data is being produced like around like 1 petabyte of data is produced every day. So the deep learning, why is it so successful? Like the reason why it's so successful is that all these large amounts of data, you can use it to make your model perform better. Like I said, I remember what I talked about in the spam example. What happened is you gave the computer a data set, spam and non-spam, and you told it to learn. Now, if you give the computer more examples of spam and non-spam, obviously the performance will be better, right? So that's the logic behind deep learning. And till now, deep learning is the most successful approach to AI. Lot of the technologies we use, is powered by deep learning in the backend. For example, like I told about self-driving cars earlier, deep learning is the main technology behind self-driving cars. 70 to 80% is deep learning. I'll just walk you through a case study so you guys get a better idea of what machine learning and deep learning is. It won't be too technical. So suppose I'm making a program to predict the price of a house. I have a program. It should predict the price of a house. Now, can you guys tell me, like, when it comes to a house, what are the factors that influence the price? Location. One more feature. Size, area. One more. House maintenance. Something that can be easily expressed in numbers, preferably. Size we defined, area. To make it simple, can I say number of bedrooms? So this is clear. So we defined 3 things that influence the price of a house: the location, the area, and the number of rooms. Now these 3 things in machine learning are called features. Now, are all these features equally important in determining the price of the house? Do they all play an equally important role? No. Some things are more important than the others. So in this, which is the most important? So area will probably be the most important, right? Area, then location, then maybe the number of rooms. So we need a way to tell the program, to tell the machine that not everything is equally important. Some things are more important than the others. So you introduce this new concept called weights. Now look at the equation. You see those x1, x2 and x3, right? Those are our features. x1 is the area, x2 is the location and x3 is the number of rooms. Now you add something called weights to it. You see those theta 1, theta 2 and theta 3. Now what would happen if the weight were to increase? The value of the whole term would increase, right? If I increase theta 1, that means the whole term, theta x1 would increase. Similar for all the terms in the equation. So, this whole equation is basically called the hypothesis function. This is the equation that you see right here is the equation the machine uses to predict the price. Now, in our case, if we say area is the most important, I put like area, the area is theta 1, I put it as the highest. So, that will contribute the most to predicting the price. You get the idea, right? Now, if location is not so important, I can reduce the weight of location. That is theta 2. If I reduce that, its contribution to determining the price goes down. So, you get the idea, right? So, now that we have our equation, we have the equation to predict the price, right? So, I told you in machine learning data is important. So, we need to give the data set to the machine. So, in most cases, the data set will look like this. How many features did we define? 3. So, that thing x of I is one feature. Not one feature, one example. Suppose our data set contains millions of examples. Okay? And you take one example. And that one example is how many features? 3. Every example will have 3 features. And corresponding to that, we give the computer the real answer, the real world answer, the real price. This is called the label. So you give the computer the features we have selected, and corresponding to those features, we give the computer the real price. Remember the equation I showed you guys? H theta of x, the equation you use to predict the price. Now, ideally, if you take the difference between our predicted price and the real price, should the difference be large or the difference be small? Small. Why should it be small? Error is minimized. This is the real world answer. This is our prediction. So the gap between the prediction and the real world answer should always be low, ideally. So this is called the loss function or the optimization function. Every machine learning model will have a loss function. And our goal should be to minimize the loss function. In this particular case, our goal is to minimize the difference between our prediction and the real world price. Got it right? So every machine learning problem, you'll have to define your own loss function and you'll have to minimize it. So there is a technique for minimizing, but it's too technical, it's too mathy, so I'm not going to get into that. How many of you guys did engineering? Did you guys learn anything called gradient descent in maths? So basically the minimization is done using that gradient descent. So after you minimize it, after you minimize the loss, how do you know, like after you minimize the loss, how do you know your model is working well? How do you know your program is working well? You will have to give it new examples it hasn't seen before. The model learned from a data set which we gave. Now, to know that it is working perfectly or it is working good, you need to give it new examples. And if it performs well on those new examples, you can say the model is good. So basically, in any machine learning problem, or when you're trying to solve any machine learning task, what engineers usually do is they start with the data. In this case, what was the data set? It was 3 features, and corresponding to those 3 features, what is the price? The real world price. So you start with the data, you organize and collect the data, you clean it, and then you pass it on to an algorithm you define for that task. It gives you an output. You test it using new examples, and then if it doesn't perform well, you go back, you tune your algorithm again and again till it performs well, and then in the end you get a good model. This is clear, right? So now I want to give you a little bit more in-depth idea into what deep learning is. You guys, I showed you a basic machine learning problem, right? So now I'll show you a basic deep, it's not a basic problem, but a very commonly used, a very commonly solved problem for deep learning, that is face recognition. You guys all use Google Photos, right? Now, if you open your Photos app, it automatically recognizes all your friends, your face, everything. You don't need to tag anyone. It tags everything in every photo. So how does it do that? How does it recognize the face of a person so perfectly and so well? You only need to show it one example of your face or your friend. Just one. And the rest it will automatically tag. So the basic idea behind deep learning is, so let's take a face, and every face will have particular edges. Your faces, your shape will always be different, everyone's. You'll have particular edges and particular contours. So remember the neural net diagram I showed you with many layers? So what it does is, the first 2 or 3 layers, or the first 100 or so layers, it will learn to detect edges. It will learn to see what edges are and which face has which type of edges. Then the next 100 or so layers, using those edges as input, will learn to see the contours of a face. That particular shape, is it indented anywhere? Then it might learn to see features. And by features, I mean your eyes, your nose, your ears. And finally, at the very last 100 or so layers, it will be able to recognize the face. So what's happening here is, at the lowest level, you get a very low level representation of the image. It's just able to recognize edges and basic stuff like that. As you go deeper and deeper, it's able to learn more and more complicated features. And in the end, it's able to recognize a face. So this is a very, very basic high-level idea of deep learning. You guys are clear, right? So this is just an image to compare traditional machine learning with deep learning. Traditional machine learning is basically the problem I showed you, the housing price prediction problem, right? We gave it an input. The input was features and the price. We defined the feature, we also defined the features. Then we classified it, or we predicted the price, whatever. In this case, our problem is giving an image and predicting whether it's an image of a dog or not. This is the problem shown in the diagram. So you give it an input, you have to define the features, and then it has to classify whether it is a dog or not. In deep learning, it does that all on its own. You just give it the input, it learns how to extract the relevant features, and it gives you the output. You don't need to define the features like we did in the housing price problem. So that's a fundamental difference between traditional machine learning and deep learning. So this is again an image showing why deep learning is so successful today. As I said, the most powerful thing about deep learning is the more data you get, the more your performance goes up. Even in the face recognition problem I told you about, if I had 1 million faces as opposed to 1,000 faces, 1 million faces is better, right? If I only collected faces from India, it won't be able to recognize a face from US or Europe or whatever. But if I had a huge data set having faces of everyone around the world, it's a much better model. Now, as I said, data is easily available. So compared to traditional programming and older learning algorithms, deep learning performs much better.